Yeah, good day everyone. Thanks for staying tuned. Yeah, this is a follow-up video on the previous video release on how to size some solar energy system, that is solar home energy system sizing. And in the first video, we discovered or we learned how to calculate our total energy demand based on some loads that we want to drive in our house. And I presented a table where some basic calculations were done. So do yourself a favor to watch it because this is a follow-up video on it. And now we are going to determine our battery bank, which is the next stage. So how do we determine our battery bank? As we all know that battery is the storage, yeah, for our inverter. Yeah, that's it store energy in the chemical form. So our battery bank, that is how to determine the battery capacity. So battery capacity is rated in AH, that is ampere hour. So this formula will be used to determine the battery capacity for our system. And the formula goes thus: E daily times DOA over inverter efficiency times the depth of discharge times the selected system voltage. So how do we go about this? Now, the E daily is E daily is the energy, the total energy demand for that building. And I think in our own case, we got, if you follow the table, we got 1930 watt hour. And this is the same thing as 1.9 kilowatt hour. Just divide the 1930 by 1000, so it will give us 1.9 kilowatt hour, or in the case 1.93 kilowatt hour. So that's the total energy demand. Is that taken? So after that, we call something DOA, and that DOA is days of autonomy. Days of autonomy. What do you mean by days of autonomy? Should there be, we are dealing with solar, and sometimes there may be a day that maybe there is no sun, and then how do you survive during that day? And this is more of the reason that you have to really design your system very well. So days of autonomy shows that, okay, for instance, if there is no sun today, if there is no sun tomorrow, will my system die down, or will I not use solar system for that 2 days? So that's where the case of autonomy comes. So you will factor it in. Okay, if there's no sun today and tomorrow, that's 2 days. So that's your days of autonomy. So it means your days of autonomy, it means your days of autonomy will be two. Do you understand? Or you are factoring it in that, okay, maybe for 3 days there will be no sun, everything will just be shadow, then it means your days of autonomy is three. So that's about days of autonomy. Then when we are talking about the depth of discharge, it means, for instance, your battery, let me say your battery charges from 0 to 100%. Are you getting it? So that's from 0 to 1. 100% means 100 over 100, right? Yeah. So which is equal to 1. Then if your depth of discharge, that is the level at which you discharge your battery. For instance, your battery charges from 0% to 100%, and you now discharge it to 50%. Then it means your depth of discharge is 50%. Then that depth of discharge, which is 50%, means 0.5. That is, you understand? Aha. So it means 0.5. If it's 60%, then you are talking about 0.6. That's how it was. That is the level at which you discharge your battery. And for all lead acid battery, you are not expected. Normally, it's good for you not to discharge your battery maybe more than 0.5. Do you understand? So that the battery lifespan will increase. So now this is the formula we'll be using. This is the formula we'll be using for the battery bank sizing. Having understood the E daily, which is your total daily energy, which was calculated in the previous video, and having understood what it means by DOA, then inverter efficiency, it means how efficient that inverter is. You know, the inverter will be converting the energy from the battery into a usable AC, that is alternating current, because the battery is direct current. So because and your appliances at home uses alternating current, you get it. So how efficient is it to convert that energy with minimal loss? So usually inverters, most inverters, good inverters, usually have at least 90% efficiency, and that 90% now shows zero. The 90% shows 0.9 efficiency. So it means the inverter is efficient enough to convert, understand, the voltage supplied by the battery into usage by electrical appliances. So next slide. So the calculation we got, I mean the answer we got from our previous video, which is the total watt hour, that is the energy demand, the daily energy demand is 1930 watt hour. Yeah, watt hour. Then now I'm not considering maybe 2 days, I'm just doing for a day, that is the days of autonomy. Yeah, so that's me times 1. Then I told us about our inverter efficiency. So my inverter efficiency is 90%, which is my inverter efficiency is 90%, which is equal to 0.9. Then my depth of discharge, I'm choosing 50% because I don't want to damage my battery so fast. So that one will be 0.5. Then the selected system voltage, I am selecting 12 volts as my system, as my selected voltage, the system voltage I want to use, because you have 12 volt system, you have 24 volt system, you have 36 volts, but 36 is not so common now, and you have 48 volts, you have 96 volt system. That is the voltage requirement to drive, the voltage required by the inverter to be driven. Do you understand? So we have 12 volt system, you have 24. These are voltage V. You have 24, you have 48, you have 96. Are you getting it? Those are the selected system voltage. Then how do I select my voltage? How do I know that I'm using 12 volts and not 24 volts and not 36 and then not 48? One, there's this table we use. If your energy, your daily, you understand, your daily energy, sorry for this for my writing. If your daily energy, total daily energy demand, falls between 0 to 2 kilowatt hour per day, you can use 12 volts. If it falls between 2 to 4 kilowatt hour per day, you can use 24 volts. If it falls between 4 kilowatts to 14 kilowatt hour per day, you can use 48 volts. Then if above 10, if it's greater than 10, then you can use 90, maybe 60. 60 is not common anyway, but above, you can just use above 48 volts. Use above 48 volts. We have 96, we have some 120 volt system. So that's how I determine. And you know that our R's fall between, our own is 1.93 kilowatt hour. So it falls between the 12 volt range. And that's how I come about selecting the 12 volts. I hope you got it. Good. So now the calculation. So 1930, which is the total energy demand in watt hour times the days of autonomy. I'm only considering 1 day, over the inverter efficiency, which is 0.9, times the depth of discharge of the battery, which is 50%, which is 0.5, times 12 volts, which is the system selected voltage. So if you do your calculations now, you will get this. I have watt hour here, watt, and watts, which is power, is the same thing as voltage times current. Voltage times current, and voltage is for V and current is I. Do you understand? So from here, if my watt is changed to VI ish over this V, do you understand? And voltage is measured in volts and current is measured in amps. So which is VA. That's my wattage. Watt for wattage. VA. You get that? So this one will now be VA. You get it? So V will cancel V. It will now remain AH, amp hour. You get it? And that's how we got this amp hour. So from here, it will be 1930 VAH all over 5.4 V. So V will cancel V. It will now remain 357.4 amp hour. And that's the battery capacity that I need to drive the 1330 watt hour, which is 1.93 kilowatt hour. Is that taken? So for me to load that system, are you getting it? To cater for all the loads, I need this capacity of battery. I need the capacity of battery. Yeah, thank you very much. So now we have gotten the capacity of the battery needed to be 357.4 AH, if I'm not mistaken. So we now want to determine the number of battery in series and the number of parallel strings. Do you get that? And now, remember I told you that our system voltage, we've selected our system voltage to be 12 volts. Then the selected battery voltage. Battery usually, they come in 12 volts. Are you getting it? Mostly they come in 12 volts, all these lead acid battery. We now have batteries that comes in 24 volts and 48 volts, mostly for lithium ion batteries, lithium ion phosphate batteries. But usually for this design, we are considering the lead acid battery. So our selected system battery voltage is 12 volts. So the battery we need in parallel or in series will be only one. 12 volt divided by 12 volt, that's 1. So that's 12 over 12, which is equal to 1. Then number of parallel strings, and let me tell you this also, that all these lead acid batteries, they come in 12 volts. We have 12 volts 50 AH, we have 12 volts 100 AH, we have 12 volts 150 AH, we have 12 volts 200 AH, we have 12 volts 220 AH, and 220 AH is the most common one. We have 12 volts. We have some too that are 12 volts, maybe 230 AH. But for this design, we are using 12 volts 220 AH. And remember that the calculated capacity is 357.4, and we've gotten the number of battery in series to be 1. So what we need now is, okay, we need to calculate the number of batteries in parallel that we need. Are you getting it? Now we know also that the required battery capacity which we got is 357.4 amp hour divided by the selected battery capacity. I've decided to select 220 Ah. That's the battery capacity I selected to be used. And now 357.4 divided by 220. That will give me 1.62. We can't find 0.62 battery in the market. Do you understand? So this one is giving 1.62. So it means I will need two, if you approximate it. I will need two batteries to be connected in parallel. Are you getting it? We need two batteries to be connected in parallel for my system. So now to get the total number of batteries, number of battery in series is 1 times number of parallel strings is 2. So I will need two batteries in total for my design. Now I said parallel. You know, if you connect batteries in series, you are increasing the voltage. If you connect them in parallel, you are increasing the capacity. Let's see this. This is one battery, and then this is another battery, and this one is 12 volts 220 Ah battery, and likewise this one too is 12 volts 220 Ah. So this is the positive terminal, this is the positive terminal, and then this is the negative, this is the negative, 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 positive, positive. So if you are connecting in parallel, your positive will join your positive, then your negative will join your negative. Are you getting it? So you now have the output will be 12 volts. You sum the capacity, that will be 440 Ah. You get that? So that's the capacity. So you can see there's an increase in the capacity. So 440 Ah minus 357.4. 440 minus 357.4, and that would be 82.6 Ah. So I'm still at the advantage of 82.6. It's better you go higher. It's better you go higher than to go lower. So that is that. So it means for my design, I will need 2 units of 12 volts 220 Ah for my system. Thank you. Thank you.